So this question is related to topic DC electricity. The circuit shows include a fixed resistor and a negative temperature coefficient. Thermistor is there, it means when the temperature increase, the resistance of a thermistor will decrease. This is also a potential divider circuit because when two components are connected in series, we call that as a potential divider circuit. Such circuit can be used to operate an air conditioning unit in a hot classroom in order to keep the classroom cool. The air conditioning unit starts operation when the potential in the secondary circuit exceed the certain value. So explain how a circuit could be set up to keep the classroom cool and show your answer should include a detail how a negative temperature coefficient thermistor works in terms of particles as well. So we have to explain in terms of particle. So these are semiconductors. Semiconductors like mostly consist of silicon and germanium, the base. Now what happened in terms of particle? Light or heat for thermistor, heat is a form of energy here. So due to the heat, the electron will come out and it increase the conduction electrons, like more electrons will be there if we have high temperature. And if more electrons are there, then the conduction increase. So we can say the resistance will decrease. So when the temperature is high, that more heat energy is there. So greater electrons or number of electrons in the thermistor will increase. And as more conduction electrons at high temperature, so resistance of a thermistor decreases. If a resistance of a thermistor decrease, because this is a potential divider circuit here, so as a high temperature resistance of thermistor decrease, so voltage across thermistor will also decrease. This is a fixed resistor. Its resistance does not change, but comparison, this will have a high resistance. So here we will have a more voltage. So in a potential divider circuit, if one side we have low resistance or low voltage, automatically other side will have a high voltage. So what will happen? This side will have a high voltage. So if we connect an air condition or AC in parallel to component X and Y, that will receive a high voltage and it will start to work. So increase in the potential across a fixed resistor. So if we connect an air conditioning unit parallel to between X and Y, it will also work. In this question, the thermistor in the circuit is replaced by a light dependent resistor. LDR is there and we connect a voltmeter. The fixed resistor has a resistance of 1.2 kilo and the EMF of the battery is 12. Initially, circuit is set up and the voltmeter displayed 4.71. So here the reading on the voltmeter 4.7 volts. When the light is shown onto the voltmeter, so initially it is 4.71 and when the light is shown onto LDR, the voltmeter reading changes to 2.16. So now initially it was 4.71, but now it is 2.16 volt. Calculate the change in resistance. So what we have to do, we have to calculate, like first the voltage is 4.71 and then the voltage is 2.16. So we have to calculate the change in the resistance. Whenever we have a potential divider circuit, like here, if I say this resistance is R1 and this one is R2. So we have the formula that R2 is equals to, or V2 basically, voltage across that component is equals to R2 divided by R1 plus R2 into combined voltage V. So the combined voltage is 12, R1 is 1.2 and R2 we have to find. So we have to find R2 and V2. What about V2? The value of a V2 will change. Like first we'll take a value of a V2 when the voltage is 4.71 volts. And then the second part we will solve the same formula we'll use, that V2 is equals to R2 divided by R1 plus R2 into combined voltage V. So, and this time we'll take a resistance as voltage as 2.16 and we'll find the value of R2. And how much increase is there. So we'll get the value of R2 by substituting a value V2 here, and V is 12. So this will give us 775 ohms. And when we solve for this one, the R2 here will be 263 ohms. And we subtract to get how much change is there. So it changes by 512. Or you can also use the formula that V1 over V2 is equals to R1 over R2. Like V1 over V2 equals R1, because the ratio of the voltage in series is same as the ratio of the resistance of the two components. So R1 over R2. So what about V1? The value of a V1 will change according to the question. First, the first part, when the V2, this is V2. If the V2 is if the V2 is equals to 4.71, then how much? Because total is 12. So we'll subtract. So V1 will be how much? It will be 12 minus 4.71. So it will be 7.29. And same thing if V2 is 2.16. So how much will be V1? 12 minus 2.16. So this will be 9.84. So we can take a ratio of the voltage and resistance, and the value of R1 does not change. The value of R1 remain constant. That is a fixed resistor which remain 1.2 kilo ohm. So using that, we can work out the value for R2 and R2 here, and then subtract to work out the change in resistance.